Alright dear children, now we go to the next part of this interference of two wave. In the last YouTube video we have done up to this relation I equals to I1 plus I2 plus 2 square root of I1 I2 cos phi. Now this is the expression that measure the intensity of resultant wave by the superposition of two wave traveling in the same medium. Okay. Now this intensity is actually depend upon the phase difference. Phi means the phase difference. That means this intensity can be maximum, this intensity become minimum. But you know children that intensity maximum means always give you constructive interference. Intensity minimum means always give you destructive interference. Okay. Now to get condition for constructive interference, the phase angle phi must be such a value so that this cos of phi become 1. Because you know cos maximum value is what? Plus 1. And when you get cos of phi become plus 1, when phi is 0 degree, 2 pi, 4 pi dot dot like that. Means when phase difference between the two wave is 0 degree or 2 pi, 4 pi dot dot like that, then cos of phi will be always plus 1. And you know plus 1 is the maximum value of cos phi. Okay. So in cos of phi is plus 1, this value is plus 1, the maximum value, then intensity also become maximum. That is I also become I max. Okay, I also become what? I max. Okay. So that means we get the maximum intensity. Which means in general the same when phi is 2 m pi, when m is starting from what? 0, 1, 2, 3 dot dot dot, then we always get intensity maximum. Means if phi is 0 out here, if m is 0, sorry, that means phi is also 0 degree. When you put m equals to 1, then phi is 2 pi. When you put m equals to 2 out here, 2 2 4 pi. That means when phi is 2 m pi, so this is the condition. Okay. Then m is 0, 1, 2, 3. Then phi, which give you 2 m pi, the maximum intensity. It give you what intensity? Maximum intensity. And this maximum intensity, that is I max, okay, is given by the relation, that is I max equals to I1 plus I2 plus 2 square root of I1 I2 into the cos of phi is how much? Plus 1. That means I become I max when cos of phi is plus 1. Since cos of phi value is what? Plus 1. Okay. And this is the relation that measures the maximum what? Intensity. But children, this relation can be even written this way also. You can write I1 as square root of I1 whole square. Because square root of I1 square means I1 only. Plus I2 can write as square root of I2 whole square. Because square root of I2 square means I2 only. Plus 2 square root of I1, and I can split this one also, I2 also. Now the reason I am writing this way is because if I consider this is A, if I consider this is B, now this relation is in the form of A plus B whole square. See, A square plus B square plus 2, A and what? This is A and this is what? B. And you know what is the formula? A plus B whole square. A means square root of I1 plus B means square root of I2 with whole square. So you can see now I max, the intensity maximum, is also measured by the relation, and that I max equals to square root of I1 plus square root of I2 whole square. Okay. Now the same relation can be even written this way also, because I1, you know what is the value of I1? Ka1 square plus, you know what is the value of I2? Ka2 square. That means the same intensity can be measured in terms of amplitude also. In terms of what? Amplitude. Okay. So for that, let me open the bracket. Okay. Square root of k means square root of k only, into square root of a1 square means a1 plus square root of k only, and this is square root of a2 square means a2 with whole square. Can you see what is common inside the bracket? Square root of k. But when you take out from the square, it will be k only. Means square root of k whole square means k only. Now what is remaining inside the bracket? A1 plus A2 with whole square. So children, look at this. The maximum intensity can also be measured by the relation in terms of amplitude of two wave by the relation k bracket A1 plus A2 whole square. Okay. Now to get maximum intensity, the phase difference must be 2 m pi. The phase difference must be what? 2 m pi. Similarly, we can write the same phase difference into path difference also. What difference also? Path difference. And children, you know path difference is marked by letter X, and the relation is phase difference is always 2 pi by lambda into X, the path difference. Now what is the general expression of phase difference? 2m pi. When phase difference 2m pi, then we can measure the path difference. So phi equals 2m pi equals to 2 pi by lambda into X, so that pi and pi cancel out, okay, and 2 also cancel out. So if you cross multiply, this is m lambda equals to X, which means your X equals to m lambda is the path difference. Means when your path difference is m lambda, where m starting from 0, 1, 2, 3 like that and on, then we always get the intensity what? Maximum. And the same maximum intensity is given by k a1 plus a2 whole square. So look at the expression, children. This intensity or constructive interference, we got the constructive interference or interference become intensity become maximum, when path difference is m lambda and phase difference is what? 2m pi. This is for constructive interference. Similarly, we do for what? Destructive interference. And children, destructive interference means the intensity become minimum. When intensity become minimum means that interference always give you a destructive interference. Okay, so destructive interference is basically for minimum intensity. This is for what? Minimum intensity. Now when for minimum intensity, or that is for destructive interference, remember this, your cos of phi must be -1, because what is the minimum value of cos of phi? That is -1. So this is the minimum value. Means when the cos of phase difference is -1, that give you a minimum value, then the intensity become minimum, and that interference is called destructive interference. But cos of phi become -1 when phi is pi, because cos of pi is how much? 180 degree, cos pi is -1. Similarly, cos of 3 pi is also -1, 5 pi -1, ... like that. So in general, if I write phi equals to 2m minus 1 pi, 2m minus 1 pi, where m starting from 1, 2, 3, ... like that, then you always get the minimum intensity. The intensity become minimum, and that minimum intensity leads to the what interference? Destructive interference. Okay, so under this case we measure the minimum intensity. So children, we can now measure the minimum intensity. That means I becomes I minimum when cos of phi is -1. So which means I write on the formula there. You know the formula is I equals to I1 plus I2 plus 2 square root of I1 I2 what? Cos of phi, the formula. But this I now becomes I minimum intensity, equals to I1 plus I2 plus 2 square root of what? I1 I2 into now this time this cos of phi is how much? -1. So cos of phi is -1. Now let me write it down. This is I1 plus I2. Now minus into plus is what? Minus 2 square root of I1 I2. So now see, your minimum intensity can be written also as square root of minimum intensity I minimum equals to I1 plus I2 minus 2 square root of I1 I2. But children, I write the same relation as square root of I1 with whole square plus square root of I2 with whole square minus 2 square root of I1 and square root of I2. Now the reason I am writing again, as I said, if I consider this is A, this is B, this is A, and this is what? B, then this is in the form of A plus B whole square, A minus B whole square, because A square plus B square minus 2AB. You know what is the formula? A minus B whole square. So I minimum is now equals to, also measure as square root of I1 minus square root of I2 whole square. Now the same expression we can write in terms of amplitude also. In terms of what? Amplitude. Because you know that I minimum can be again written as I square root of I1, as I said, k A1 square minus I2 means k A2 square. So the expression is similar as we have done for maximum intensity. So I can write directly this expression as k A1 minus what? A2 whole square. So now see the children, the expression of minimum intensity can be measured as k bracket a1 minus a2 whole square. So this is the expression that measures the minimum intensity for what interference? Destructive interference. But this destructive interference obtained when phi is 2m minus 1 pi. But the same minimum intensity is also obtained since your phase difference that is what? Phi, we can write phi also equals to 2 pi by lambda into what? X. X is what difference? Path difference. So what is phi? This is 2m minus 1 pi equals to 2 pi by lambda into x. So pi and pi again cancel out. So if I make x as the subject, it will be 2m minus 1. This lambda will go this side, numerator, and 2 will come in the derivative. Now look at the expression. Your phase difference, your minimum intensity will also be obtained when the path difference, this is x is path difference, is 2m minus 1 lambda by 2. And children, in this case, your m basically start from 1, 2, 3 like that and all. Because if I substitute m equals to 1, 2 1s are 2, minus 1 is 1, that is lambda by 2. Okay, that is a path difference. If I put m equals to 2, 2 2s are 4 minus 1, that is 4 minus 1 is 3 lambda by 2. So that means when we do with the path difference also, the intensity become minimum, and to get minimum intensity, your path difference must be this much. This is the path difference. So children, remember this, to get constructive interference, that is for maximum intensity, and to get destructive interference for minimum intensity, there must be a phase difference and path difference. The phase difference become maximum, okay, for constructive interference, and phase difference become minimum, cos of phi become plus 1 for constructive interference, cos of phi become minus 1 for destructive interference. Therefore, when we observe this interference, okay, we always get a bright and dark, means minimum intensity and maximum intensity, and means we get alternate this constructive and destructive interference. We get one region maximum intensity, another region minimum intensity, again maximum intensity, minimum intensity. That means the intensity changes in an alternate manner. One become maximum, one become minimum, and such type of pattern which is formed is called interference pattern. And this phenomenon which makes the modification in the distribution of energy, okay, either light energy or sound energy, by the superposition of two waves or more than two waves in a medium is also called interference. Now in the next video we learn the condition for interference, and the last topic that we need to discuss is called bits.